Internet, a system architecture that has revolutionized mass communication, mass media, and commerce by allowing various computer networks around the world to interconnect. Sometimes referred to as a network of networks, the Internet emerged in the United States in the 1970s but did not become visible to the general public until the early 1990s. By 2020, approximately 4.5 billion people, or more than half of the world's population, were estimated to have access to the Internet. And that number is growing, largely due to the prevalence of smart technology and the Internet of Things, where computer-like devices connect with the Internet or interact via wireless networks. These things include smartphones, appliances, thermostats, lighting systems, irrigation systems, security cameras, vehicles, even cities. The Internet provides a capability so powerful and general that it can be used for almost any purpose that depends on information, and it is accessible by every individual who connects to one of its constituent networks. It supports human communication via social media, electronic mail, email, chat rooms, newsgroups, and audio and video transmission, and allows people to work collaboratively at many different locations. It supports access to digital information by many applications, including the World Wide Web. The Internet has proved to be a spawning ground for a large and growing number of e-businesses, including subsidiaries of traditional brick-and-mortar companies, that carry out most of their sales and services over the Internet. The Internet is a global network that comprises many voluntarily interconnected autonomous networks. It operates without a central governing body. The technical underpinning and standardization of the core protocols, IPv4 and IPv6, is an activity of the Internet Engineering Task Force, IETF, a non-profit organization of loosely affiliated international participants that anyone may associate with by contributing technical expertise. To maintain interoperability, the principal namespaces of the Internet are administered by the Internet Corporation for Assigned Names and Numbers, ICANN. ICANN is governed by an international board of directors drawn from across the Internet technical, business, academic, and other non-commercial communities. ICANN coordinates the assignment of unique identifiers for use on the Internet, including domain names, IP addresses, application port numbers in the transport protocols, and many other parameters. Globally unified namespaces are essential for maintaining the global reach of the Internet. This role of ICANN distinguishes it as perhaps the only central coordinating body for the global Internet. Regional Internet Registries, RIRs, were established for 5 regions of the world. The African Network Information Center, AFRI-NIC, for Africa, the American Registry for Internet Numbers, ARIN, for North America, the Asia-Pacific Network Information Center, APNIC, for Asia and the Pacific region, the Latin American and Caribbean Internet Addresses Registry, LACNIC, for Latin America and the Caribbean region, and the Réseau IP Européens, Network Coordination Center, RIPE-NCC, for Europe, the Middle East, and Central Asia were delegated to assign IP address blocks and other Internet parameters to local registries, such as Internet service providers, from a designated pool of addresses set aside for each region. The National Telecommunications and Information Administration, an agency of the United States Department of Commerce, had final approval over changes to the DNS root zone until the IANA stewardship transition on October 1, 2016. The Internet Society, ISOC, was founded in 1992 with a mission to assure the open development, evolution, and use of the Internet for the benefit of all people throughout the world. Its members include individuals, anyone may join, as well as corporations, organizations, governments, and universities. Among other activities, ISOC provides an administrative home for a number of less formally organized groups that are involved in developing and managing the Internet, including the IETF, Internet Architecture Board, IAB, Internet Engineering Steering Group, IESG, Internet Research Task Force, IRTF, and Internet Research Steering Group, IRSG. On November 16, 2005, the United Nations-sponsored World Summit on the Information Society in Tunis established the Internet Governance Forum, IGF, to discuss Internet-related issues. The communications infrastructure of the Internet consists of its hardware components and a system of software layers that control various aspects of the architecture. As with any computer network, the Internet physically consists of routers, media, such as cabling and radio links, repeaters, modems, etc. However, as an example of internetworking, many of the network nodes are not necessarily Internet equipment per se. The Internet packets are carried by other full-fledged networking protocols, with the Internet acting as a homogeneous networking standard, running across heterogeneous hardware, with the packets guided to their destinations by IP routers. Internet service providers, ISPs, establish the worldwide connectivity between individual networks at various levels of scope. End users who only access the Internet when needed to perform a function or obtain information, represent the bottom of the routing hierarchy. At the top of the routing hierarchy are the Tier 1 networks, large telecommunication companies that exchange traffic directly with each other via very high-speed fiber optic cables and governed by peering agreements. Tier 2 and lower-level networks buy Internet transit from other providers to reach at least some parties on the global Internet, though they may also engage in peering. An ISP may use a single upstream provider for connectivity, or implement multi-homing to achieve redundancy and load balancing. Internet exchange points are major traffic exchanges with physical connections to multiple ISPs. Large organizations, such as academic institutions, large enterprises, and governments, may perform the same function as ISPs, engaging in peering and purchasing transit on behalf of their internal networks. Research networks tend to interconnect with large subnetworks such as GIANT, Gloriad, Internet2, and the UK's National Research and Education Network, JANET. Common methods of Internet access by users include dial-up with a computer modem via telephone circuits, broadband over coaxial cable, fiber optics, or copper wires, Wi-Fi, satellite, and cellular telephone technology, e.g. 3G, 4G. The Internet may often be accessed from computers in libraries and Internet cafes. Internet access points exist in many public places such as airport halls and coffee shops. Various terms are used, such as public Internet kiosk, public access terminal, and web payphone. Many hotels also have public terminals that are usually fee-based. These terminals are widely accessed for various usages, such as ticket booking, bank deposit, or online payment. Wi-Fi provides wireless access to the Internet via local computer networks. Hotspots providing such access include Wi-Fi cafes, where users need to bring their own wireless devices, such as a laptop or PDA. These services may be free to all, free to customers only, or fee-based. Grassroots efforts have led to wireless community networks. Commercial Wi-Fi services that cover large areas are available in many cities, such as New York, London, Vienna, Toronto, San Francisco, Philadelphia, Chicago, and Pittsburgh, where the Internet can then be accessed from places such as a park bench. Experiments have also been conducted with proprietary mobile wireless networks like Ricochet, various high-speed data services over cellular networks, and fixed wireless services. Modern smartphones can also access the Internet through the cellular carrier network. For web browsing, these devices provide applications such as Google Chrome, Safari, and Firefox, and a wide variety of other Internet software may be installed from app stores. Internet usage by mobile and tablet devices exceeded desktop worldwide for the first time in October 2016. The International Telecommunication Union, ITU, estimated that, by the end of 2017, 48% of individual users regularly connect to the Internet, up from 34% in 2012. 69 Mobile Internet connectivity has played an important role in expanding access in recent years, especially in Asia and the Pacific and in Africa. 70. The number of unique mobile cellular subscriptions increased from 3.9 billion in 2012 to 4.8 billion in 2016, two-thirds of the world's population, with more than half of subscriptions located in Asia and the Pacific. The number of subscriptions was predicted to rise to 5.7 billion users in 2020. 71. As of 2018, 80% of the world's population were covered by a 4G network. 71. The limits that users face on accessing information via mobile applications coincide with a broader process of fragmentation of the Internet. Fragmentation restricts access to media content and tends to affect the poorest users the most. 70. Zero rating, the practice of Internet service providers allowing users free connectivity to access specific content or applications without cost, has offered opportunities to surmount economic hurdles but has also been accused by its critics as creating a two-tiered Internet. To address the issues with zero rating, an alternative model has emerged in the concept of equal rating and is being tested in experiments by Mozilla and Orange in Africa. Equal rating prevents prioritization of one type of content and zero rates all content up to a specified data cap. In a study published by Chatham House, 15 out of 19 countries researched in Latin America had some kind of hybrid or zero-rated product offered. Some countries in the region had a handful of plans to choose from, across all mobile network operators, while others, such as Colombia, offered as many as 30 prepaid and 34 postpaid plans. A study of 8 countries in the Global South found that zero-rated data plans exist in every country, although there is a great range in the frequency with which they are offered and actually used in each. The study looked at the top 3 to 5 carriers by market share in Bangladesh, Colombia, Ghana, India, Kenya, Nigeria, Peru, and Philippines. Across the 181 plans examined, 13% were offering zero-rated services. Another study, covering Ghana, Kenya, Nigeria, and South Africa, found Facebook's Free Basics and Wikipedia Zero to be the most commonly zero-rated content. The Internet standards describe a framework known as the Internet Protocol Suite, also called TCP/IP, based on the first 2 components. This is a suite of protocols that are ordered into a set of 4 conceptual layers by the scope of their operation, originally documented in RFC 1122 and RFC 1123. At the top is the application layer, where communication is described in terms of the objects or data structures most appropriate for each application. For example, a web browser operates in a client-server application model and exchanges information with the Hypertext Transfer Protocol, HTTP, and an application germane data structure, such as the Hypertext Markup Language, HTML. Below this top layer, the transport layer connects applications on different hosts with a logical channel through the network. It provides this service with a variety of possible characteristics, such as ordered, reliable delivery, TCP, and an unreliable datagram service, UDP. Underlying these layers are the networking technologies that interconnect networks at their borders and exchange traffic across them. The Internet layer implements the Internet Protocol, IP, which enables computers to identify and locate each other by IP address and route their traffic via intermediate, transit, networks. The Internet Protocol layer code is independent of the type of network that it is physically running over. At the bottom of the architecture is the link layer, which connects nodes on the same physical link, and contains protocols that do not require routers for traversal to other links. The protocol suite does not explicitly specify hardware methods to transfer bits, or protocols to manage such hardware, but assumes that appropriate technology is available. Examples of that technology include Wi-Fi, Ethernet, and DSL. For locating individual computers on the network, the Internet provides IP addresses. IP addresses are used by the Internet infrastructure to direct Internet packets to their destinations. They consist of fixed-length numbers, which are found within the packet. IP addresses are generally assigned to equipment either automatically via DHCP, or are configured. However, the network also supports other addressing systems. Users generally enter domain names, e.g. n.wikipedia.org, instead of IP addresses because they are easier to remember. They are converted by the domain name system, DNS, into IP addresses which are more efficient for routing purposes. Internet Protocol version 4, IPv4, defines an IP address as a 32-bit number. 75 IPv4 is the initial version used on the first generation of the Internet and is still in dominant use. It was designed to address up to 4.3 billion, 109, hosts. However, the explosive growth of the Internet has led to IPv4 address exhaustion, which entered its final stage in 2011, when the global IPv4 address allocation pool was exhausted. Because of the growth of the Internet and the depletion of available IPv4 addresses, a new version of IPv6, was developed in the mid-1990s, which provides vastly larger addressing capabilities and more efficient routing of Internet traffic. IPv6 uses 128 bits for the IP address and was standardized in 1998. IPv6 deployment has been ongoing since the mid-2000s and is currently in growing deployment around the world, since Internet Address Registries, RARs, began to urge all resource managers to plan rapid adoption and conversion. IPv6 is not directly interoperable by design with IPv4. In essence, it establishes a parallel version of the Internet not directly accessible with IPv4 software. Thus, translation facilities must exist for internetworking or nodes must have duplicate networking software for both networks. Essentially all modern computer operating systems support both versions of the Internet protocol. Network infrastructure, however, has been lagging in this development. Aside from the complex array of physical connections that make up its infrastructure, the Internet is facilitated by bi- or multilateral commercial contracts, example peering agreements, and by technical specifications or protocols that describe the exchange of data over the network. Indeed, the Internet is defined by its interconnections and routing policies. A subnetwork or subnet is a logical subdivision of an IP network. 16 The practice of dividing a network into two or more networks is called subnetting. Computers that belong to a subnet are addressed with an identical most significant bit group in their IP addresses. This results in the logical division of an IP address into two fields, the network number or routing prefix and the rest field or host identifier. The rest field is an identifier for a specific host or network interface. The routing prefix may be expressed in classless interdomain routing, CIDR, notation written as the first address of a network, followed by a slash character, slash, and ending with the bit length of the prefix. For example, 198.51.100.0/24 is the prefix of the Internet Protocol version 4 network starting at the given address, having 24 bits allocated for the network prefix, and the remaining 8 bits reserved for host addressing. Addresses in the range 198.51.100.0 to 198.51.100.255 belong to this network. The IPv6 address specification 2001 DB8:32 is a large address block with 296 addresses, having a 32-bit routing prefix. For IPv4, a network may also be characterized by its subnet mask or net mask, which is the bit mask that when applied by a bitwise AND operation to any IP address in the network, yields the routing prefix. Subnet masks are also expressed in decimal notation like an address. For example, 255.255.255.0 is the subnet mask for the prefix 198.51.100.0/24. Traffic is exchanged between subnetworks through routers when the routing prefixes of the source address and the destination address differ. A router serves as a logical or physical boundary between the subnets. The benefits of subnetting an existing network vary with each deployment scenario. In the address allocation architecture of the Internet using CIDR and in large organizations, it is necessary to allocate address space efficiently. Subnetting may also enhance routing efficiency or have advantages in network management when subnetworks are administratively controlled by different entities in a larger organization. Subnets may be arranged logically in a hierarchical architecture, partitioning an organization's network address space into a tree-like routing structure. Computers and routers use routing tables in their operating system to direct IP packets to reach a node on a different subnetwork. Routing tables are maintained by manual configuration or automatically by routing protocols. End nodes typically use a default route that points toward an ISP providing transit, while ISP routers use the border gateway protocol to establish the most efficient routing across the complex connections of the global Internet. The default gateway is the node that serves as the forwarding host, router, to other networks when no other route specification matches the destination IP address of a packet. While the hardware components in the Internet infrastructure can often be used to support other software systems, it is the design and the standardization process of the software that characterizes the Internet and provides the foundation for its scalability and success. The responsibility for the architectural design of the Internet software systems has been assumed by the Internet Engineering Task Force, IETF. The IETF conducts standard-setting work groups, open to any individual, about the various aspects of Internet architecture. The resulting contributions and standards are published as request for comments, RFC, documents on the IETF website. The principal methods of networking that enable the Internet are contained in specially designated RFCs that constitute the Internet standards. Other less rigorous documents are simply informative, experimental, or historical, or document the best current practices, BCP, when implementing Internet technologies. Thank you for watching this video.